So part A wants to know how many people are in the auditorium when the concert begins, and this is just the rate at which people enter the auditorium. So we're going to integrate that rate from 0 to 2 hours. Should be pretty straightforward. That should be sort of what you do for all these ones. It's usually on the rate questions. Part A is like how many people, how many fish, how many bananas, whatever, right? They just integrate the rate function. So what did that come out to be? Should it come out to be 980? And that was worth 2 points. 1 for the integral and 1 for the answer. Everybody good with part A? Straightforward enough. What about part B? We want to find the time when the rate at which the people enter is at a max. So how do we determine when the rate is at a max? When its derivative is equal to 0. Those are potential times at which the rate could be at a maximum, right? So you had a calculator, but you needed to take the derivative to graph it anyway. So you take the derivative, you graph it, you see when it's equal to 0, and that came out to be what? T equals 0 and T equals 1.36296 were the possibilities. Oh, or 2, right, because of our endpoints. And then you would have just checked each of those to see which one was the largest. R of 0 is clearly 0. R of 1.36296 was 854.527. And R of 2 was 120. So which one of those is the biggest? That one, right? 850 is more than 120, which is more than 0. Yeah. That was worth 3 points. 1 point for seeing when R prime was equal to 0. 1 point for getting the correct interior critical point, and 1 point with the correct answer with the justification that all the other ones were less than that. Any issues with B? Austin, you good with B? Oh, good. Okay. All right. People in the Zoom, are you good with B?
Yeah.
Okay. Great. Part C. The total wait time. So we have a total wait time. We add the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. Okay, exciting. W is the total wait time for all the people. The derivative of W is this. We want to find W of 2 minus W of 1. Well, if we're given the derivative of W and we want W of 2 minus W of 1, how could we set up an integral to find this value? Exactly. We'll just integrate W prime from 1 to 2, right? That should be the integral of W prime, which is W evaluated at 2 minus W evaluated at 1. So you've got a calculator. You'll just have your calculator evaluate that function out. And that comes out to be 387.5 hours total wait time of all the people. And that was worth 2 points. 1 point for the integral and 1 point for the answer. Good? Pretty good there? Yeah. Part D, we want to know on average, how long does a person wait in the auditorium for the concert to begin? We're considering all people who enter the auditorium after the door is open. So what is the total amount of wait time for everybody? That ought to be what's the total amount of wait time that everybody has? Be what? Yeah, and then what do we need to do with that? We need to divide it by, not by 2. Not by 2. What do we need to divide that by? So total, that's the total amount of wait time. We want to know on average how much each person waits. Divided by 900, what is it, 980? So we'll divide it by 980. And we've got the integral from 0 to 2 of w prime dt, which should be, what does that come out to be? Looks like 0.77551. Hours. So each person waits about 45 minutes, a little more than that. And that was 2 points, 1 for the integral, 1 for the answer. So 0 to 2 is the integral of w prime. So that's the total amount of wait time for everybody between t equals 0 and t equals 2 divided by the number of people that were waiting. Should give you the average number of time each person waited. Make sense to everybody? Any questions or issues with that? All right. Those of you taking the June 9th test, any other specific types you want to go through? Otherwise, I'll just start picking some. All right, a differential equation one it shall be. Let's see. I believe we did that one and that one. We did the bird. I think we did that and we did the trash. Should we do this one? Yeah, we did that one. I don't think we did this one. I don't think we did that one. No? All right. We're going to do a couple differential equation ones today then. At least for now. We'll see how things go towards the end. We might do something else at the end. Yeah, differential equation, separable differential equation, xy cubed. No slope field though. All right, I'll give you, what do you think? Do you need 15 minutes or no? We'll see. All right, ready to go. Okay, part A, write an equation for the tangent line to f at x equals 1. So anytime we need a tangent line, we need a slope, we need a point. The point is given to us, 1, 2. We need the slope, so we'll plug in 1, 2 to dy dx. To find that value, looks like that should be 8. So we've got y minus 2 equals 8 times x minus 1. Good? Yeah? That was worth 2 points. 1 point for the slope, 1 point for the equation. Part B says use your tangent line approximation, so the thing we got from part A, to approximate f of 1.1. And that part should be easy. Y minus 2 equals 8 times 1.1 minus 1. So that's 0.1, right? Times the 8 is 0.8. And then we add the 2, we end up with y equals 2.8. If you just did that much, you got 1 point. That was worth 1 point. But then they want to know, given that our function is always positive between 1 and 1.1, is the approximation for f of 1.1 greater than or less than f of 1.1? So how do we figure that out?
Concavity of the original function.
Concavity of the original function. So if our original function is concave up, the tangent line will be below it. If our function is concave down, the tangent line will be above it. It'll be an overestimate. So we need to go back in and look at our concavity at the point 1, 2, right? So if we do that, or even better, I mean, we know that the y value is always positive and the x value is always positive. I mean, it tells us that y is always positive on this interval, and we know x is always positive on this interval. So we should be able to say that the second derivative, if both x and y are positive, and we've got a positive number cubed times a positive number plus a positive number times a positive number times a positive number, all of that is positive. True? This is definitely positive on the interval, right? So if it's concave up, then it must be an underestimate. It's an underestimate. F of x is concave up. And that's about all you had, right? And that was worth one other point for that, yeah? Yeah. 1 point. Okay. So remember that the concavity is what affects whether it's an under or an overestimate for a tangent line. If it's a secant line, the concavity also affects it, right? Secant line, if it's concave up, is an overestimate, and if it's a secant line and concave down, that's an underestimate. But they're asking tangent lines here. So. All right, then we're going to find a particular solution with the initial condition that f of 1 is 2. So we got dy dx equals xy cubed, and that x equals 1, y equals 2 is our initial condition. So these are pretty much always with the differential equations, they're almost always separable differential equations. So we got to get the y's on the side with the dy and bring the dx to the other side. So we'll have dy over y cubed equals x dx. Just doing that is worth 1 point. Okay. Then we probably rewrite the y cubed as y to the negative 3 dy. And integrate both sides. Integral of y to the negative 3, it goes up to y to the negative 2. You divide by negative 2, so that's negative 1 over 2 y to the negative 2, or 2y squared, equals x squared over 2, plus a constant. They gave you 1 point for the correct antiderivatives, 1 point for the plus c. Then you need to find the c, so you'll plug in your initial condition. X equals 1 gives you a half plus c. Y equals 2 gives you negative 1/8 on the left. So you end up with a constant of negative 5/8, right? You do negative 1/8 minus a half, negative 5/8 is our constant. So we're now looking at negative 1 over 2y squared equals x squared over 2 minus 5 over 8. And then we just solve that for y. If you want to get a common denominator here, you can. I don't know if they did. Yeah, it looks like no. It looks like they. No, it looks like they didn't right away. It's up to you. If you want to get a common denominator right away and then just take the reciprocal, you can. That's probably what I would do. So I'd rewrite this as negative 1 over 2y squared equals 4x squared minus 5 all over 8. And then I'd flip it. Negative 2y squared equals 8. Over 4x squared minus 5. I'd multiply by negative 1, which would just make it 5 minus 4x squared in the denominator. I'd divide by the 2, which will just make the numerator a 4. And then I'd square root. And when I square root, I get plus or minus this. But we know that the y value we need to get out is a positive number. So we're not going to put a negative square root because we need to get a positive number. So we'll do the positive square root. And let's see, I said, yeah, finding that constant was the 4th point, and then getting the final equation was the 5th point, I believe. Yeah. Yep. Yep. Good? Not good? Negative, sorry, say that again, if you wrote it as what? square root of negative 1 over 5 fourths minus x squared, something like that. Yeah, that's fine. Yeah, it doesn't have to be written this way. Anybody have any questions on that? Austin, you good with that one now? Serena, you good with that one? The rest of you all took it already, right? Trying to make sure, or are not taking it, right? People in the Zoom, you good with that or no?
I'm good.
Great. People that are taking the June 9th test, other free response types you want to work through? Or should we do another differential equation? Another differential equation? Sure. There's A and B. All right. Let's do this. I think we did this one. Let's do this one. This will be a fun one. Everybody will like this one, I guess. I'll give you 15 minutes. Ready, go. So y minus 1 squared cosine pi x. Let's think about, first off, when y is 1, what's this going to be? Should be 0 every time when y is 1. Easily enough, right? Y is 1. That should be 0 times something. So 0. When x is 0 and y is 0, we're going to have the cosine of 0, which is 1, and we're going to have negative 1 squared, which is 1. So that ought to be 1. It doesn't really look like 1, but that looks better. X equals 1, y equals 0. We've got the cosine of pi, which is negative 1. And then we've got negative 1 squared, which is positive 1. So we'll have a negative 1 there. At negative 1, 0, we're going to have a 1 from this first term. And then cosine of negative pi is also negative 1. So that ought to be a negative 1. And then we'll plug in 1, negative 1. That should be the cosine of pi. And then it should be negative 1 minus 1. So negative 2 squared. So 4 times negative 1, and negative 4. When x is 0, that's again 1, and y is negative 1. That should be a positive 4. And then when x is negative 1, that's still going to be a negative 1. And when y is negative 1, that'll be a 4. So another negative 4. And that was worth 2 points. 1 point for these 3. 1 point for these 6. So 1 point for all the ones where it was 0, 1 point for the rest. Good? And it says there's a horizontal line with equation y equals c that satisfies this differential equation. Find the value of c. Well, what's c? C ought to be 1. Should be able to just see that, right? The line y equals 1 is a solution to this differential equation, right? Just that horizontal line. So that was worth 1 point. Then for part D, that means there was 6 points for solving the separable differential equation. So first thing would be dy over y minus 1 squared equals cosine pi x dx. When we try to integrate both sides of that are going to need a u substitution. For the left, it's going to be u equals y minus 1. And du is just dy. And for the right, we'll call it v. V is pi x with dv equal to pi dx. So we'll need to put in a pi and a 1 over pi there. And so we'll end up with an integral of du over u squared, or u to the negative 2 du. And over here, we'll have 1 over pi times an integral of cosine v dv. And then we'll be able to integrate both sides. So integral of u to the negative 2 should be negative 1 over u. And over here, we'll have 1 over pi cosine, 1 over pi sine of v. So sine of pi, and plus c. So you got 1 point for separating the variables, 1 point for correctly integrating this side, 1 point for correctly integrating this side, 1 point for having a plus C. Then you define the constant. What was the initial condition that they gave you? X is 1, Y is 0. So when X is 1, oh, I should have changed that into a U, out of my U. This is negative 1 over U, which is negative 1 over Y minus 1. So when X is 1, we've got 1 over pi times the sine of pi. Sine of pi is 0. So 1 over pi times 0 is 0. So we just have constant. And we got negative 1 over, well, 0 minus 1 is negative 1. So we get a constant of 1. So we're now looking at negative 1 over y minus 1 equals 1 over pi sine pi x plus 1. And for getting that constant, that was another point. So that's 5 points. And then solving it the rest of the way gives you the last point. So you can take the reciprocal of both sides. So you'll end up with negative y minus 1 equals 1 over all of this. And then we can get rid of the negative. And then we can just add 1. So we end up with y equals 1. And then minus 1 over pi sine pi x plus 1. And you might have simplified it slightly differently, but that's probably fine. They multiplied everything by a pi to the numerator and the denominator to clear out the 1 over pi, but not necessary. That was your last one. Everyone good with that? Feeling like we're getting the hang of the differential equation ones again? Yeah? What do you guys think? Another one of those, something different? Something from the miscellaneous? Area of volume? Zoom people for June 9th, Serena, Austin? No preference? Serena, you have a preference? No preference. Zoom people that are taking the June 9th test, any preference? Otherwise, I'll just come up with something. Cool. All right. Let's do another area volume one. Let's see here. I think we did that one. I don't believe we did this one. That one look familiar to anybody? No? All right. So I'll give you the last few minutes of class here to finish this one up. This will be the first one we talk about tomorrow. And ready to go.